Hey guys, we're going to talk about different kinds of real numbers. So real numbers are any rational or irrational number, and we're going to denote that or signify real numbers with this double-stemmed R. So if you see that, just know that it means real numbers. So we'll start with the irrational numbers. Irrational numbers cannot be written as a fraction. It'll have a decimal that goes on forever, but there will be no pattern, and the decimal won't repeat. Rational numbers, on the other hand, can be written as a fraction. It could have a decimal, but the decimal will end or it will have a pattern to it. Integers are positive and negative whole numbers, meaning that they don't have any decimal. And then whole numbers are positive integers, but we also include 0, so 0 on up. Lastly, we have natural numbers, which just is strictly positive integers, so 1, 2, 3, 4, 5, etc. So if we look at numbers, 7, the most specific subset of real numbers would be the natural numbers. -3 is an integer, and the square root of 80 would be an irrational number. Here is kind of a table that shows you how all of these are related. So everything is a real number, and then you take your real numbers and split it into rational and irrational. So I gave you some different examples of each of those. Pi is a really common irrational number, as well as square roots. Just be careful that your square root can't be simplified, because I could have the square root of 49, but we know that simplifies to 7, so that square root would not be irrational. Rational numbers can be fractions, they can be positive, they can be negative, they can be decimals, repeating decimals, ending decimals. Then we go to integers. Integers don't have any decimals, but they could be positive or negative. Whole numbers, the smallest whole number is 0, and then we go on up from there. And then natural numbers, your smallest natural number would be 1. Today we're also going to talk about different properties that hold for both addition and multiplication. So the first one would be closure. So whenever you take a real number and add another real number, you always get another real number. Same with multiplication. One real number times another real number will always end in a real number as well. Then we have the commutative. So the commutative property is where you can add in any order or multiply in any order and get the same result. So 3 plus 5 is the same as 5 plus 3, or 2 times 7 is the same as 7 times 2. We also have the associative property, which means that we can add in any order. So I could add A and B and then add C, or I could add B and C and add A at the end. Same with multiplication. So that property will hold over addition and multiplication. Then we have a property that kind of incorporates both addition and multiplication. So we have the distributive. Some of you remember this as a rainbow property. So you take A and distribute it to B and C. So you get AB plus BC. Another property is the identity. So identity means that we want what we start with. So I want to be able to add something to a number without changing the original value. And in addition, that identity would be 0. So I can add 0 and it won't change my original value. In multiplication, that identity is 1. So 1 times anything gives us that same number. So the multiplicative identity would be 1. We also have the inverse. An inverse means that I want to add or multiply so that my result is the identity. So in addition, I want to add something to my number to get 0. Well, that's just the opposite. So if it's 3, I want to add -3, because that would become 3 minus 3, which is 0. In multiplication, if I have 5 and I need to multiply by something to get 1, I would need to multiply by 1/5 or 1 over 5. So 5 times 1 over 5 would be 1. The one stipulation with this rule is that A cannot be 0. Okay, a couple questions for you guys. First, I want you guys to identify the smallest subset of numbers that -13 belongs to. And then tell me what property is being shown here.